Let's rapid revise and memorize some of the very useful generalized results related to the minimization of DFA. Okay, according to my convenience, I have divided the results into three types. That is, first depends on the binary numbers, that is divisible by n. Second depends on the length of the string, and third depends on the substring. Okay, so first let's talk about the type 1 results. Okay, that is number of states in minimal DFA that are required that accepts all binary numbers divisible by n, where n is, according to n we are categorizing it into different types. Okay, if n is odd, then simply number of states will be equal to the n only. Okay, number of states will be equal to n only. And if in case if it is even, okay, that further will depend on the value of n. That is, if n is equals to 2 to the power k, or n is not equals to 2 to the power k. Okay, if n is equals to the 2 to the power k, then what happens is, n is equals to 2 to the power k, then simply the number of states that will be minimal DFA will be equal to k plus 1. And if n is not equals to 2 to the power k, then again two possibilities occur. That is, if n by 2 is even and n by 2 is odd. Okay, if n by 2 is odd, then it's very easy. That is, n by 2 is odd, then we can simply say that the number of states will be equal to n by 2 plus 1. Okay, and if n by 2 is even, then we have to consider something. That is, if n by 2 is even, that is, we have to divide it by 2 until we get an odd value. Okay, plus k will be added to the to get the minimal DFA. Okay, generalized rule that specifies the number of states in minimal DFA that accepts all binary number divisible by n, where n is odd and n is even. If n is even, if it is equals to 2 to the power k, it is equal to k plus 1. And if it is not equals to 2 to the power k, then if it is n by 2 is even, that it is n by 2 by 2 until it gets an odd value plus 2. Or if it n by 2 is odd, then we will get the minimal number of states as n by 2 plus 1. This is the case that we get the number of states in minimal DFA that accepts all binary number divisible by n. Okay, n can be 1, 2, 3 and so on like that. Okay, we'll discuss it in the next lecture with related to examples, and it will be more clear then. Okay, now consider the type 2 generalized results. Okay, first of all you need to only remember the 3 or 4 statements. That is, if minimal DFA that accepts exactly n length string will require n plus 2 states. Okay, that has to be memorized. And then minimal DFA that accepts at least n length string will require n plus 1 states. Okay, and the minimal DFA that accepts at most n length string will require n plus 2 states. Okay, this is different, and these both are n plus 2, so you can remember like that. Okay, exactly n, n plus 2, at least n, n plus 1, at most n, n plus 2. Okay, and the minimal DFA that accepts the length of string divisible by n will require exactly n states. Okay, these 4 you have to remember, and based on that you will be able to solve hundreds of many of the questions in the exam. Okay, now the minimal DFA that accepts even length string means divisible by n, divisible by 2. Okay, so using this formula, that is, accepts length of string divisible by n will require n states, so divisible by 2 will require 2 states. So here we can say that that accepts even length string will require 2 states. Now for odd length string, it depends on the number of states in even length string. Why? Because for the odd length string we have to complement the DFA obtained for even length string, and for complementing only the thing required is that to make the final states as non-final and non-final states to final states. So number of states will be same in both the even length strings and odd length strings DFA, so it is same, like that is 2. Okay, Now the minimal DFA that accepts number of B's at least 2. At least 2 can be found by this formula, that is at least n will give require n plus 1 states, that is here n is 2, so it will require 3 states. And number of B's divisible by 3 is exactly 3, that is here, that is in the fifth we can say fifth statement. Length of string divisible by n will require n states, so divisible by 3 will require 3 states, so here 3. Number of B's not divisible by 3 you can obtain by complementing it, and number of states will be same as divisible by 3, so we are getting 3 only. Okay friends, so we have obtained type 2 generalized result. Now we are heading towards the type 3 generalized results, and it is also very simple. And the minimal DFA that accepts all strings of length strings of A's and B's, that is all strings of A's and B's where each string ending with n length string. N length string, that is suppose we have to obtain a we can say a language that ends with ABB, that is length of the string that it ends is 3, so n length is n equals 3, that is a 1 2 3, so n is equals to 3 will require how many states, that is how many states are required that ends with particular n length string, that will require n plus 1 states, you have to remember that. Okay, minimum DFA that accepts all strings of A's and B's where nth input is nth input is A from LHS will require n plus 2 states. Suppose we have got something that is A or B, A plus B. Nth input symbol is, suppose third input symbol is A from LHS. Okay, rest I don't know about it. Okay, like this, that is first, second, third position is A. Then what number of minimum number of states that is required is n plus 2, that is third, 3 plus 2, that is equals to 5 states is required in this question, particular example. Okay, like this we have to proceed. Now 13, the minimal DFA that accepts all strings of A's and B's where nth input symbol is A from reading from RHS. From right hand side, if we are getting nth input symbol as A or B, we can say if we are saying A, then it can be written as this. Nth input symbol is, suppose we are getting third input symbol from right. Okay, third input symbol from right, we can write it like this. So the minimum number of states that will be required is 2 to the power n. You have to remember it. Okay, 2 to the power n means if it is a third from the right hand side, then 2 to the power 3, that is 8 states are required. That's a big number. 2 to the power n is a big number, that's why NFA are created. Okay, that particular example is basically telling about the use of NFAs. Okay, the 14th is the minimal DFA that accepts all strings of A's and B's with substring of length n. Substring of length n means we are getting something that is A plus B star. Okay, and here blah 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 A B n length string it is. Okay, substring. Then A plus B star. Then how many states are required is also given by n plus 1. Okay, suppose we have got A plus B star, that is A B B in between substring, and this particular example will require 4 minimum states for minimal DFA. And that is all for generalized results, and in the next lecture we are going to solve the questions based on that, and that is very crucial to solve the particular problem.